Good morning, everyone, and welcome to today's guest speak. Joining with us today as the guest speaker is an amazing mind in the software industry who is here to give us a valuable insight of Git and GitHub. So, without further delay, let me introduce today's guest speaker. Joining with us today as the guest speaker is Mr. Shalita Suranga, Senior Software Engineer at 99X. On behalf of the Department of Information and Communication Technology of the Faculty of Humanities and Social Sciences of the University of Jayewardenepura, I warmly welcome you, sir, to share your knowledge with us today. I'm sure that all of our participants will be able to get a clear understanding about Git and GitHub at the end of today's session. So now let's get started with today's program. And before that, I would like to remind all of our participants that if anyone has any question to be cleared out by the speaker while we are progressing through the session, please feel free to send us your question via the chat box, and we will direct it to the speaker at the Q&A session, which will be conducted in the latter part of today's program. And now it is over to you, Mr. Shalita.
Thank you. Hello, everyone. Hope you all can hear me.
Yes, sir, you are audible.
Yeah, nice. So I will get started. First, I will share the screen. Hope you can see my presentation. I think it's
Yes,
at
sir,
the
we
end.
can see your presentation.
Yeah, nice. Still, you can see the screen, right?
Yes, sir.
Yeah, nice. So today's session is about GIT and GitHub. So this topic, so GIT and GitHub is a kind of a very good knowledgeable thing for you. So when you are developing software related things, so when you are making mobile applications, when you are developing web applications, so these topics are very helpful. I will let you know why. So you probably heard about these two topics, GIT and GitHub. You maybe already worked with these two things. But let's get started from the beginning. I will explain you why JIT is needed, why GitHub is needed. So what are the things behind those things? So this session is divided into two sections. So very first, I will be going through some kind of introduction session, some kind of theoretical aspects of JIT and GitHub. So I'm not diving too much deep into the theoretical because it could be a bit boring for you to if you go a bit further into theoretical things during I think few hours. So you can lazily learn more about the theoretical things later. So I will give you kind of a introduction, no hints about theoretical aspect. Then I will focus more into the kind of practical session. So I think you all are using computers right now, so you maybe can try what I am doing. If I create something, you also can try, I think. So I think you probably don't install JIT yet, but I think during my session you can try to install, and you can try to enter the commands what I enter. You can just follow, I think, what I'm doing. So I will give you some time while I am doing things. So very first, let's get started. So first I will give some kind of a quick introduction to myself. So I am Charlita. I think I already heard some introduction from about me. So but I will give quick words about me as well. So I am Shalita Suranga, working at 99X, and I am contributing open source software around the world as well. So I am initiating open source projects and doing stuff on GitHub as well. So let's get started. So first, we can start with the software project. I think you all are working with kind of software project, no? I think your university project, I think you are doing with your university projects, and maybe you are doing some group projects. So these projects can be categorized into, I think, three types, mainly three types. There can be other types as well, but mainly we are working with these three types. First, we have desktop application. Desktop application means some kind of application that we run inside your computer, right, on operating system. So next we have web applications. So web applications basically run inside the web browser, right? So if you are making a web application, then your users need to use it. Then your user need to download the web browser, then they need to access your web application where their browser, right? They need to have a browser. For desktop applications, they need to have a operating system. For web apps, they need to have a kind of a web browser, right? It can be mobile web browser or a desktop web browser. So finally, we have mobile apps. So mobile apps, as we already know, they run on mobile devices. So we have Android devices, iOS devices. So we can make applications for those things. So we are working with software projects, right? So by the way, can anyone let me know about quick words about maybe desktop application or web application or mobile application you work with for your university project or something? Can I mean someone can tell about the desktop application you built? It's okay to like unmute and tell. I think if you build some kind of web application, maybe a calculator or something, you can tell I built a calculator using C# or using Java. So I think you can tell on chat also. I think someone put some stuff, no? Money stack projects are nice. So web apps means what kind of web app? Kind of what kind of web app? Maybe kind of user management app. Or I assume that it can be like any kind of web app. So you may already work with web apps. So you may already work with desktop apps. So I think someone and blog app is nice. So users can see blog post and admin using the admin panel. We can maybe post new blog posts. So that is nice. So you already work with those things, right? So I think I skipped one slide. We can go a little bit back. So next we can check about software development. So when we are working with software projects, we can call it software development, right? When we are developing software. So if there's a one developer, assume that there's a one developer called John. So John is going to work on a food ordering application. So maybe we can assume it is maybe Android application. Then he created the Android application. He tested it. Then he released into Play Store. Then user can download and use it, right? So can you assume the where is the code of this food ordering app? There's only one developer, right? It is probably in his computer. He already coded. He started his project inside the folder maybe. So he is working on his code on his device, on his computer, right? That's very simple. There's one developer. The code is in his computer. So that's very straightforward, right? So that is very simple. So what if his computer has a trouble? Then he need to switch a computer, right? Maybe he's going to upgrade the computer to new machine. So what he need to do is he is going to get the new machine. Then he need to copy this source code and into new machine, right? He need to set up everything and he is going to copy the code into new machine. So that is also doable, right? That is very simple. Just copying the code into new device. So there can be problems. What if there are two developers? So assume that there's maybe John has a brother called Vic. So Vic is going to code in the same application. So the food ordering application is started by John. So he's the founder. He started the application, but maybe we can assume that there are many features. There may be many users. So he need to speed up the development. So he asked his brother Vic to join the food ordering app development. So now Vic is also coding, John is also coding. So how they are going to work? Yeah, yes, so it is also doable. John can share the code with this Vic. We can assume that Vic also in his John's maybe house. Both are living in the same house, right? So what John can do is, so John can put the code into maybe a USB drive, pen drive, or maybe portable hard disk. Then John can give the source code into Vic, right? So we can add new stuff, new features, maybe new delivery options or whatever. then they can update the code, then they can give they can put, I mean, we can put this newly added code into new source code, then we can hand over the USB drive back to John, right? Now John has the latest code, so John can update his code by copying all files from the USB drive. Then he can also compile, he can also work on the same application. So there's a problem. You can see what is the problem. We've already noticed, maybe the both persons cannot work at the same time, right? Assume that John added some kind of a new screen to maybe see pizza options in a food delivery app. So Vic is going to add extended, maybe Vic is going to add new maybe new flavors to the pizza. So they cannot work at the same time. Do you know the reason? The reason is that if they work on the same code, so how they are going to share the code? There's a problem. Then if let's assume that John is going to update the same page, then Vic is going to update the same page, then how they are going to merge, how they are going to combine the source code. So there's a problem, right? So the only solution is here to manually going through the each change and updating and kind of combine those two solutions, right? Those two features. There's a problem, as you can see. But if they are not going to work at the same moment, if John is going to work maybe morning, if Vic is going to work on maybe night, so there's no problem, because they can hand over the using the previous method, right? Using the USB stick. John is going to implement, then he's going to hand over to Vic, then he's going to implement, Vic is going to hand over to John. So there's a cycle, but there's a problem. They cannot work together at the same time, right? So we can check next. So it is getting more complicated. So there's a quiz going on, I think. So there's a problem again, right? But in the previous case, is two developers case, we had the problem because they cannot work together at the same time, right? So because they are going to copy the code and hand over to other person, right? So if there are more developers, assume that the food ordering application is getting popular now, then it has like 1 million downloads now. So John decided to start a company around this food ordering app, maybe Uber Eats. So it is called Uber Eats, right? So he started the company Uber Eats. Now there are 20 developers, because if the user base grows, they need to add new features frequently. They need to look after the application carefully, right? So the two developers are not enough, right? In that case, so within this among these 20 developers, there is Vic also. Vic also as a developer. So John is the owner. He is going to work on the application. There are 20 developers, then how they are going to update the code? So they need, I think, then now 20 USB devices, because one is going to bring the code and hand over to John, then he is going to update. Then it is very complex, no? You can think. So it is very hard to manage code manually for software applications when there are more people. So one of the developer can join from another country, right? How they are going to, how is going to, he or she is going to hand over the USB drive? Very trouble. They are in very trouble, right? So we need some kind of solution here, because it is very hard to work on same application by sharing code, right? By sharing code, it's very hard to work manually. So if there's one developer, it is very easy, because there's only one developer, he's going to update the code. If there are two developers, it is also somewhat easy, because there are two developers. One developer can work at one time, then another developer is going to work on another time. So it is also doable. But if there are more developers, then it is very complex, right? Complex to do things manually. So we need to automate this flow with some kind of tools. So John is now in a problem. So he's looking for a solution to solve this scenario. He needs some process, right, to update the code automatically. So when they are submitting, he need to update the code automatically. So there's a problem and we need the solution. So we can check next. So he got an idea. So idea is that he is thinking, how about if we store the main code in a kind of centralized space, maybe in a server, maybe on the internet. We are going to store the code in kind of centralized location. So this code is always up to date, right? So if new developer is going to work on this code, maybe adding a new feature, so he's going to download the code, then he's going to update his changes, or he's going to maybe do some bug fixes, then he's going to update the change, then he's going to submit the code to the main server, to the main location, right? So there's some magic. I will tell you the magic. There's some magic, then the code is automatically updated with this change. So there is no need to go through the things manually and update each file or copy the source files manually. The thing will be automatically updated when they are going to submit the code. So John can get the code. So John can just download the latest code and see the code, right? He also can update the code and submit something. Then the centralized code is always up to date, right? So this is the solution. So he is looking for a kind of tool to achieve this solution. So there is a solution, but we need some kind of tool matching that solution, right? John is not going to make a system for around this one. So he's not going to make some kind of code sharing platform. He is looking for kind of a solution, right? Because his job is to work on this food ordering app and make it successful. He's not going to make something like a code sharing platform, right? So it is his kind of, it is in out of context of his work, right? So he's looking for now a tool to accomplish this workflow, right? Now we can check next. So there's another problem. So in the previous version, I cannot tell about versions because if we check a mobile application, it is always up to date. No, there you cannot download basically the previous version via Play Store. No, we are always downloading the latest code. So I will tell another example. So just keep that mobile application about that food ordering app aside and think about notebook. So assume that the same person, John, is going to implement a notebook application. It is a desktop application, right? Where you can write a note and save note. Likewise, so it is a very simple notebook application. You can assume that it is very similar to Notepad, right? So very first, he is going to release the first version. You know about versions. Versions means some kind of state of the application. If we check Windows XP, Windows XP is some kind of, I think, 6.0 5.0 version. So later came another version. Now we have, I think, Windows 11. So those are versions, right? Kind of state of the source code. So now very first we have the first version. So first version, we have some limited number of features. They can save notes and maybe they can update notes, they can delete notes, so whatever. So assume that this version 1.0 supports only local things. You cannot share notes, right, in this v1.0 thing, first version. So John decided to create a new version. So in the new version, he can maybe share notes to other people. Like you got that Zoom join link, then maybe they can generate a link to open the specific note of the notebook. So maybe like that. So in 2.0, you can work with remote notes. So there are two versions now, right? Two versions are he's going to work on both two versions. So we assume that there's a bug in the first version. Maybe when you are saving notes, when you're adding one, maybe when we're adding some kind of another extension instead of maybe txt, so there's a kind of error. So he's going to fix and apply the fix into this version. So we are applying changes into this version, right? So maybe he released another version called v1.01. So it is just a bug fix for this version. So assume that there's another bug happened in this version, maybe some kind of internet connectivity issues, right? So he's going to work on this version, then he's going to apply fixes. As you can see, there's another problem, right? We need to manage versions. software can have different versions. So as you already know, I already explained earlier, Windows XP has Windows platform has several versions. We have XP, we have 7, likewise we have 10, now we have 11. So they are still working on, I think they are still applying patches to Windows 10, right? Because Windows 10 has some kind of things need to be improved, but they are still working on Windows 11, right? They're working on multiple versions. I think you got the point. So we need some kind of solution to manage versions and also manage the code sharing thing, right? So we need to find a solution. So what's the solution? We have Git and GitHub. So we are going to learn on those two things, right? Now you already know the problem behind code sharing, problem behind versioning. So we have two things. Then to solve those two things, we have two solutions, right? Git and GitHub. Very first, we are going to learn about Git. So these are just theoretical things. So don't worry, you don't get any kind of I think deep understanding about this one. You just need to like get some kind of overview about these things. So while I'm doing the practical session, you will get more understanding about these things. So these things, I think these theoretical things, just to like give introduction to you, right? So what is GIT? I think if you search on maybe Google, it will tell GIT is a kind of maybe distributed version control system. So you won't get that point, right? If you are new to GIT, you don't understand what is what is the distributed version control system. So within these simple terms, you will understand. So what is GIT? GIT is kind of a tool to manage files with versions, right? We have set of files. It can be maybe not only source files, it can be images, there can be videos, right? Git is a solution to manage files with versions. So with versions means we have one version today, maybe you are implementing application today, then you are adding a new feature tomorrow. So there are two versions, right? Today's version and tomorrow's version. So within using Git, you can work with those two versions. If you make a mistake yesterday, you can go back to yesterday's version of your code, right? Then you can find the issue. You can maybe apply a fix like that, right? So what is Git? Git is a tool to manage files with versions, right? It is also a tool to track version history. Like I mentioned, you can go back. It is like time traveling. You can go back to another day and you can see what are the changes you did, you or other person did, right? But you cannot go forward because it hasn't happened yet, right? You can only go backwards, right? You can see what are the changes for each file also, you can see, right? So what is Git again? Git is a tool to build software collaboratively, right? Earlier, we were building, John was building software collaboratively, right? With another 20 developers, including Vic, right? So they are building software collaboratively as a team. So wait, we need another thing here. So we need GitHub. Git can alone, what Git can do alone? It can basically work locally, right? So if we need to do something collaboratively, we need internet connection, of course, because we are going to share something. So do the work collaboratively, we need GitHub as well. So what is GitHub? We already know Git. It is a tool to manage files and files with versions, and it is a tool to track version history. So what is GitHub? Wait, we can see, right? But first, we need to learn some important points about Git. There are some terms, there are some kind of buzzwords or some kind of technical terms about Git. So while I'm doing the practical session, I will use these terms. So if when I say repo, so don't confuse. Just understand this term. While I'm doing the practical, I will use these words, right? So first, be familiar with these things. So what is repo or repository? The repository means a kind of Git project. So to work with Git, you need to convert your normal project as Git project. So I will tell you how you can do it. So first, understand repo or repository is a Git project. So while you're working with maybe Photoshop, so you call your project is Photoshop project. So when you're working with Git is the repository. So in that previous case, while you're working with Photoshop, the repo is like PSD file, no? Because it is a kind of a Photoshop project. So when you're working with Git, Repo is Git project. So repository, when someone is telling you, here's my repository, he means that he or she means that it is a repository, a Git project, right? Repo means Git project. Branch means some kind of development flow. I mentioned that earlier there can be versions, right? Version 1.0, 2.0, or maybe another feature they are implementing. So there can be different flows. I will explain the flow little bit later. Now just understand branch is a kind of development flow. It is like versioning, version 1.0, 2.0, 3.0, likewise. So there's merging. So what if we need to combine the code, if we what if need to, like, if we create development flow today to implement a new feature, so if tomorrow we may need to merge that feature into our main development code, right? The latest code. So if we do such merging, such kind of combining, we call it merging in Git, the workflows. So we have merging. Merging means just combining two development flows. So we have commits. Commit means some kind of one change. It is a change. You maybe update the file, you maybe remove the file, you maybe fix the bug. So that is kind of a change, right? Some kind of node in this flow, some kind of point. I think you will know about graph theory. You probably work with graph theory. So it is like node in graph. Some kind of change happened in the development flow. So we have staging. Don't worry about these things. If you don't understand, probably you can understand while I'm doing the practicals, right? I will do the practical soon. So staging means before making a commit, we can select that what are the files we are going to commit, we are going to apply into this Git project. So we can just say it is staging. So we are going to pick files. So if you modify two files, if you need to add both files, you need to stage those two files, right? I will tell you when I'm doing practicals, but just understand staging means getting the files ready for committing. So we're going to pick some files and get ready to for committing. So those are the terms you need to make sure to understand, right? So what is GitHub? We already understood. Git is this. Git is you already know. Git is this kind of tool. So what is GitHub? To work collaborated, we need GitHub. So what is GitHub? GitHub is a website, right? We can access web app. We can navigate into the GitHub using a web browser. It is a web application, right? So using GitHub, you can host Git repos. It means that when you are working with the Git project, you can copy the entire Git project into a remote location, right? In the previous I think diagram, so we have some kind of remote centralized location, right? To keep the up-to-date code to download and to update as well. So this is the centralized location. It is GitHub. So GitHub is not only there are other solutions as well. So other Git hosting services as well. I think you heard about Bitbucket. There are several services. Bitbucket, I think GitLab. There are other services, but today we are going to discuss about GitHub. So using GitHub, you can host Git repos. It means that you can basically bring your Git project into remote location, right? To then other developers can download the repository, and they can work. I will explain how they can work in the tutorial session. So let's understand what is GitHub. It is also a website to manage centralized Git repos. I already explained that we can create centralized Git repos in a kind of a server. So those projects, those Git repos are created in a server on the internet, right? So it is also a web app to build software collaboratively. But wait, we need Git as well. GitHub alone cannot build software collaboratively, because we need, it is just a website to host Git repos, right? We need Git, developers need to install Git to interact with the centralized location, right? Then we need Git. I think you understood how those are connected. Git needs GitHub to have a place to store code, centralized place, right? We need a centralized place, so it is provided by GitHub. So if you are discussing with GitHub, we need a tool, or developers need a tool to interact with the centralized location to download the code, to update the code. They need the tool, right? The tool is Git. I think you understood the point. What is Git and GitHub, right? So next, what is next? So this is how the John solved the problem. So what he did, he asked developers to use Git. So he is also using Git. Now other 20 developers are also using Git. So he created a repository, remote repository on GitHub. So what they can do, so let's assume that one developer is going to update the code by adding maybe a feature, right? New, maybe a fixing a bug. So he is going to update his local repo. Local repo means the repository in his computer, in the developer's computer, right? He's going to update the local repository. Then he is going to update the remote repository, right? Then he is going to, then Git will take care of that. Then they don't need to like copy the code manually into remote repository. There's a commands in several commands in Git. So there's a command to update the remote repository. So we are going to push the changes to the word, this term is push, right? I will tell you in the tutorial session. So we are going to push the code into remote repository. Then this code is updated. This GitHub, the remote repository code is updated, right? So after that, so John also can get the latest code. How they're going to get, how John is going to get the code. So using Git, then John can download the latest code. Then he can download this remote repository code, the latest change to his local repo, right? Then he has the latest code. Now I think you got the point. Earlier I told you don't get anything if the Google says Git is a kind of decentralized version control. Now you got the point, right? Now you can understand, I think. So everything is decentralized. It means that each developer has a local repo. This developer has a local repo. This developer has. So maybe they are working in different things, right? This one developer is fixing a bug. Maybe one developer is updating a documentation. Maybe another developer is adding a feature. Likewise, they work on different things. Maybe John is updating another thing, right? So they are having different decentralized, means different local repos there are, right? But there's a centralized repository to have the latest code. So if a new developer joins the team, he or she can download the code from this remote repository. Then he or she can submit the changes into this repository, right? The remote repository. Then they all can update the code. So I think now you all understood the point behind Git and GitHub. So we can check more about flow. I think there are only 2 slides, right? And then I'm going to jump into the tutorial session. So the flow is, I just need to visualize this one, because I think you may not get previously what I told about. It is kind of graph, no? The whole flow is kind of graph. So there are nodes. So assume that in this point, maybe yesterday, John found a bug. So he's working on some kind of development flow. His flow goes in this orange dot, right? Orange dot belongs to John's branch. John, I will tell about the branch. So branch means just a development flow. I think I explained. So this is the John's flow. This is yesterday, maybe tomorrow. Not tomorrow. I think yesterday. I think this is today. Maybe this point, the last orange point is today. So John found a bug now. Then he mentioned the Vic to fix the bug. So please help me, Vic, please fix this bug, he said, right? Then at this point, at the second, I think orange point, then we created a new branch. New branch means new flow from this point. These are commits, right? In this commit, he created new development flow. Now he is working simultaneously, right? Now he is working, this John is maybe working another thing, right? He updated the documentation. They can work at the same time. I think if you go back at the previous slides, I think I said that if you are going to share the code manually, we cannot work simultaneously. We cannot work at the same time, right? The reason is that it is very hard to apply changes, or combine changes together. But in this solution, Wiki is also going to update the source code, right? John also updating the source code. Now there are two flows, but we need basically one flow, right? One latest code is needed finally, right? What they are going to do is they are going to just combine the code. So it is called merging, right? I told you earlier. Merging basically means that combining two development workflows. So this is weak flow. So weak flow ends when he was like he found the bug and he fixed the bug. Now his flow is over, right? He's going to combine his changes into this Jones timeline, right? Now those things are merged. Now the timeline goes. Now there's one version of the code, right? There likewise there can be different flows. Maybe at this point another developer can create a branch and they can work on a different thing. They can likewise it is like very complex to think. Maybe for large software development projects, right? There can be a lot of nodes going on, different things. Some branches never ends, because if let's assume that another developer started the branch, but he decided to quit this project, so he's not going to submit his changes back, right? So likewise, there can be ending flows as well, but this flow is merged, right? Combined. So at this point, what John has? John has his codes and Wix fix as well. Wix code also merged. Then they can work together again, right? This is basically the flow. So in the tutorial session, now I am going to start in the tutorial session. I am going to cover these things. First, installing Git and how to set up it. Next, I am going to create some local repositories, right? I also mentioned what is a repository. Next, I am going to show you how we can stage and how we can commit. Next, I am going to explain how we can branch and how we can merge. Basically, how we can do this thing. So next, I am going to show you what is GitHub and how we can work with it. So next, I am going to show you how you can like create a new repository on GitHub, remote repository. Then how we can update it from your local repository. Then how we can get latest changes back. So finally, I'm going to show you the latest features in GitHub. What are the other features? So maybe GitHub Actions. Maybe I can show you those things in this section, useful features in GitHub. So after doing these things, I will show you what is actions and what is the actions feature and what are the other features as well. Maybe I can show you some examples. So maybe from my open source project, I can show you how actions are working. Likewise, so that is fine for you. I think I will remember to mention it. So next, finally, I'm going to show you likewise, including GitHub Actions, how the entire soft, like basically open source teams work. So I mentioned that I work with several open source projects. I can show you like how we are working. So that's the goal today. So now I am going to start with the tutorial section, right? I think if you are having, I think you have on Windows system, right? Maybe you can put the operating system here, maybe in the chat. Anyone using Linux or Ubuntu? Or all are using Windows? I think all are using Windows, or anyone using Ubuntu? Because there is another way to install, right? However, then I can assume that you all are working with maybe Windows, so maybe you're working with Ubuntu. Then I will give hints about how to install Git on Ubuntu as well. So I'm going to open my browser now. So if you're going to install now, so I already installed Git. So but I will mention how to install. So if we just enter Git, so there's a website Git, this Git SCM. So Git version control website is this one. So if you go to downloads, so you can download for each version. So if you're on Linux, you can click this version, click this page, and there's like set of command to install. It is very easy. This apt, using apt package manager, you can install Git. So if you
I think people can't see your screen. I think you haven't shared that.
Maybe I will reshare then. I'm resharing again. Now you can see your
Yeah, yeah. Now we can see that. Thanks.
thanks for mentioning. I think I am quite I think new to Zoom, so usually working on Teams, so that's okay. So
Okay, no worries, no worries. Okay.
yes, that's right. So I think you missed the screen from this point. So you just need to enter JIT on Google. So it will open up. It will show this website called JIT SCM, jit-scm.com. So if you go there, there's a link called download. So according to operating system, you can select. So if you're on Linux or another Linux distribution, or maybe another Unix system or whatever, so you can use these commands according to the your distribution. So I am using, I think, in my personal computer Ubuntu, so I installed JIT using this command. You can copy and run on your terminal, right? If you are on Linux platform. So if you're on Windows, you can just download the stuff. So according to, I think it is automatically downloaded. So if you, according to your like processor type, it can be like 32-bit, 64-bit, you can download, right? So using this link, you can just download. I think you already installed. So if you already installed, then you can open. I think if you go to this start, if you're on Windows, so if you open, I think just type JIT, there's something called JIT bash, right? Using JIT bash, you can enter JIT commands or other Linux commands as well on Windows platform. So if you enter JIT here, you can see set of things, right? Just the kind of documentation, small documents. So if you are seeing this, it means that you are already installed JIT. So maybe I think while I'm talking, you can just install, or you can try whether you can check whether your computer has JIT, right? Probably I think you has JIT, right? So I will continue from there. Previously, I mentioned I'm going to show you how to create repos, JIT repos locally, right? So I am creating repos in this folder. And maybe you can create a new folder, maybe whatever the folder name you wish. So you can create like that. So very first, maybe assume that I am going to create a new, maybe a new coding project, new project, not a mobile application, but simple, maybe hello world program, right? So for that, you need to create first a folder. I'm going to create a folder. Maybe it is called maybe GitHub GitHub demo app, maybe something like that, right? You can maybe, I think while I'm doing, you can do the same thing, right? You can try out these things. So now I created the project, right? So there's nothing about nothing related to JIT right now, right? So it is basically about the project, your project, right? So you're going to create maybe a file. Maybe you can create your project here. So I'm going to open Git bash, but you can create a file manually because I am very familiar with Linux. So I will enter some Linux command. So to create a new file, I will use touch command. So maybe I think you are familiar with JS, no? JavaScript, I think so. I can write
Yeah,
some
they do.
example. Yeah, right now I think I can write some example using JS. So I'm going to create a file called maybe app.js. So inside, let's assume that this is the application, this is my application. So inside this thing, I can write the whatever code I need. So I can open this one. So I can write maybe simple hello world program. So maybe I can show you like hello world, right? Hello, maybe GitHub, because we are working with GitHub. Git slash GitHub, maybe like that. So we can run this one using Node. It works, right? So this is just a hello world program, right? It is very simple. So maybe let me add another comment here, because we can say that this is my first application, maybe something like that. First version, or maybe first, I think first app or something like that. So now the project is created, right? How you are going to share this one? I mean, let's assume that another person is going to request this one. So he mentioned that he or she mentioned that they need to work on this project. They need to apply some fixes. So they need to introduce some kind of features. So how you are going to share this one? Like the old-fashioned method, you can put this one into USB flash drive, then you can hand over. But we are or using internet, maybe you can send an email, or you maybe can like put into Google Drive. But there's a problem. I think I already explained and how to what if there are more developers, so they cannot like directly update the code properly, because multiple persons cannot work on the like same, I mean, at the same time. There are troubles, right? I already explained. So what we can do is we can create a JIT project around this one. So how we can do it? You can open this terminal. I think you can right click here. I think after installing JIT on Windows, you can see these things. But if you're on Linux, you can open the terminal and do the same thing, right? So if you are on Windows, I am going to click on here. So to create a JIT project, I need to convert this folder as a JIT project, right? To convert it, I need to enter one command. It is called JIT init. So it means that I am going to create a new JIT repository using this folder. So once I this one, it says that empty JIT repository is initialized. So it is created. So how it is created, how it is going to track the changes. So there's a special folder called .jit. So if you are not seeing this, you can click, I think, show hidden files or something. You can tick this one. So if we are seeing this, so it means that JIT repository is created. What if you delete this one? Then you loses all the version history, right? So all the changes, all the JIT related things is stored in this folder. You can see a special configuration and also objects. Object means some kind of versions. Version or whole graph. I mentioned about graph, right? The graph information is stored inside this object thing, right? So there are some special things as well, but I think you can learn more about these things, I think, from the internet, maybe, because it is very time consuming to like go through all the internals, right? It is very nice to like great to study about the internals of JIT. Right now I am going to work on, I think I mentioned I'm going to show you how to create. So I created already, but how to, I mean, if I just created this one, the files are not tracked yet, right? Because I just created empty repository, right? It is empty. So how to add this file into our repository? We need to manually add this file. I mean, there can be many files. This file into our repository. So there are two commands to do that, right? Two means first you can enter one thing, then you can do one thing, right? Do another thing. So very first, I need to say I need to include this file into this repository. So how we can do that? There's a command called git add. Git add means if you can enter git status. Status means we can see the current status of the repository. So if I enter like that, it says that this file is not tracked yet. It means that this is not in the repository. It is just a file in your folder. It is not added into this project, right? So it says that we need to add it. So if you need to add it, just run this git add command and the file name. So if I add it, you can add like that also, but we are not going to do that, because if there are a lot of files, you need to add the file name likewise, and it is very long command, right? So or you can add one by one like that. This file, it is not existing. I'm just showing you examples. So if there is another file, you can add like another file, but we are not going to do that. There's a shortcut to do that. So if you enter git add dot means all the files we are going, all the untracked files we are going to add into, we are going to track, right? Just enter this one. So if I enter git status again, it is saying that all the file is tracked. It says it is earlier it is shown like this is untracked, right? This file is not tracked into your version control, your version history. So I just added it. Now it is added, but it is kind of stage. Stage means not yet committed. I mentioned right earlier. Staging means getting ready to commit. Commit means to submit into repository. So I said that this is ready to be committed. This is I mean I am okay to submit this one into my this Git graph, Git flow, right? Now I can commit it. So before committing, you need to do a couple of things. So you need to check, I mean, to commit it, we need to say, we need to store who is the person going to commit it, because version cannot be stay alone, right? If you are going to do something, there's a person behind, right? You are going to do it, or your friend is going to do it. There's a person. So to set up it, you can enter this command. Like you can search for this one from internet as well. Git global config user dot name. Then if you enter this one, you probably, I think I did a mistake here. It is not the right command. Just enter this one and see. Something happened with the global command. There's a way to update your global. I mean, if you are creating multiple repositories, not in this repository, you can update your name globally, right? So there's a command. I think something happened with that one. Oh, now it is working. So git config global and user.name. So if you are seeing this name, that is okay. If you are not seeing this, you can enter your name like this, right? Just do it if you are installing Git first time. I think if you did it, if you already installed, you already set up this one. So there's another thing. So every person need to have email in Git, right? So there's a kind of unique key to identify user. It is this one. So this is my email that you can update your email by adding like that, right? This is the basically a setup. So we are saying you are basically identity to the Git, right? So once it is done, you can do the commit. So I again enter Git status. So this is need to be committed. So how I can do the commit? You can go ahead and enter this command, git commit, and the commit message by -m, right? If you are adding we basically add a lot of words, right, with spaces. For that we need to enter this quotations, double quotations or single quotations. So within this section you can enter the message. So I can say like my first application is created or something like that. Now it says it is committed. It means that I think if you go there, now set of data is, I think set of things are created. Now your graph is created. So if you go check git log means you are just checking the history. So if you check history, you can say I committed this change. So it says that my first app is created. Now this file is tracked, right? So I think you can try to do the same thing if you are with the Git terminal right now. So now we checked, I think, committing and staging, right? So we can do another thing. We can maybe try to do another change. So I'm going to open the same file. Let's say that I did a small mistake here, maybe, right? So I'm going to enter the first step, right? So I change this one. So how I can see the changes? So I am going to open, I think, so maybe I close the, yeah, it is already open. So I'm going to enter GT status. Now this is modified, right? Earlier it shows that previously it is untracked, right? If it is modified, we can see the differences. So what are the changes? What are the things I did? So if I enter git diff, right? Git diff command, git difference, I can see the difference between this version, this change and the previous commit. So change is this one. I can easily show you. See, so usually when we develop software, we usually enter git diff before we are going to submit the code, because we may do some kind of maybe a additional, maybe if you are developing software, additional console logo by some mistake. So to verify that, we usually enter git diff. we are going to check like are there any changes, mistakes or something like that. So no mistakes. So I added this one. So I'm going to enter. I'm going to say git track this change. So I'm going to enter git add, then git commit. It's very simple. Git add, git commit, right? Then now I'm going to say maybe fix an issue with the commit, right? You can say always better to add clear messages. So I think there's guidance for that. Git message conventions or something. I think this one. I think it is always great to like see these kind of documentation. It is saying that these kind of commit messages are very good. Basically, the larger projects maintaining this kind of commit messages. So there are several conventions, right? You can also create your own convention maybe. So for an example, if you are working with maybe bugs, you can say that this is a fix kind of this kind of fix dash or something like that. You can follow your own convention, right? So I'm going to commit this one. So I said git store this change. So it is tracked, it is a stage, then it is stored, right? Now this git is updated, right? So I can enter git log and see the change. So if you need, you can go back to this change as well. Right now I'm not going to do that because it will complicate this thing, because this is very simple tutorial very first. So maybe later I will try to do that. So this is git log, means basically showing the history. I did this one, right? Someone can see there. So if someone broke your software, you can see who broke the software, so by checking the commit list, right? So now I covered, I think, staging and committing, branching and merging. So it is very simple. So branching means, so assume that you are going to, this is your main project, right? Main version, right? So if someone requested the code, you are going to basically provide this code. So assume that you are going to fix a kind of bug that you don't know whether you have solution. So it is kind of maybe tricky bug. So you're going to apply some maybe workarounds, then you're going to work it, right? So you are, in that case, you are not going to update this. This is called main branch, right? If you enter branch, you can see the branch. So master means this is the main branch. This is the latest code. So you are not going to touch it, right? Usually we don't submit some kind of bug fixes and such stuff directly to the master, because if someone requested this code, you need to provide this code with your bug fix, quick bug fixes, right? Those are maybe contain another bug, so some trouble will happen. So what we basically do is that, assume that I am going to do a bug fix, right? What is the bug fix? Maybe I need to remove this dash thing and enter and something like that, right? So for that, what we usually do is that I'm not going to update master, because if someone requests, it is very trouble. I'm in trouble, no, because I need to hurry up and complete this one, and I cannot work leisurely, because if someone, if I'm going to work on master, I think you got the point. If I am going to work on master, if someone requests the master code, I cannot hand over, because I am working on it. It is kind of a trouble situation, right? So what I'm going to do is I'm going to create a new branch and switch into that branch. So it is, branch is basically a flow, right? I am going to create a flow from this point. For that, I am going to enter git checkout dash branch, means I am going to create a branch called maybe bug fix. So I'm going to fix a bug, this dash bug in here. Don't like I think as a bug. I'm going, just as an example I am showing, right? So I created this one bug fix branch. Now I am in bug fix branch. You can see here I'm in bug fix branch, right? So I am, so assume that I am going to fix the bug right now. So this should be an not dash slash. So I'm going to see the changes git. So this is okay, this is fine. So I'm going to commit. While I'm doing, I think I can try to fix the bug. So I fix the bug. Fix the bug. Okay, see git log. So now have first step is created, like, oh, that's okay, the fix a bug. But what is the problem? So I am in bug fix flow, right? Not in the branch. Assume that then my colleague request this, hey, give me the code or something like that. Show me the previous code. So what I can do? I can just go to the master. It is like time machine, right? So I am going back right now into history. Git checkout master. So something happened. I can see this one. Now it says that we need to reload this one because it is updated. So this is the previous code. I can see git log. So where's the other commit? So other commit in the other flow, right? It is kind of graph. So I am in the main flow. I can now give you the source code, show the source code into my colleague. So hey, this is the code, this is the bug, and I am fixing that bug in the other flow. Maybe another universe kind of thing. So I'm going to another universe now. How I can go to it using git check out. What is the universe name? Bug fix, no? So that I think that colleague went now, he checked the code and I explained this one. This is the bug. I am working on it. So I switched it. So it is changed. So here is the fix. So this is in another thing, right? Another branch. I can enter git branch. So this is the bug fix branch. It is created from this master branch, right? Using git branch, we can see the history of the branch. So what I need to do, so I assume that I fix the bug. So now I fix. So now I am ready to merge this one, ready to combine this fix into other master branch, right? Master branch is the main branch. It is the main source code. So now this is okay. So now I can work leisurely, right? The reason, because I am in another flow. No one is touching this one because everyone is working on this one, but no one is working on this one. Everyone working means everyone fetching the code from this one. So if I'm not adding incomplete work to master, so I'm adding my incomplete work. Maybe today I fix this one. So tomorrow maybe I added another thing. So it is not enough. This is okay. So not tomorrow. Maybe I think yesterday I added the previous change. Today I added this one. So it seems like that we cannot go into the future. No, always in Git we can go backwards. So it is status. I can add. So maybe adding some stuff and stuff like that. Always good to check, but make sure while we are doing those things, you make sure that you are in the bug fix branch, right? If you are committing into master, then you are in a serious trouble because you are again updating the master branch. So to make sure that you always check git status before doing anything. It says that on branch bug fix. Otherwise, master you need to check out into bug fix. So now assume that now I am done with this one. It is okay, safe to be deployed, safe to be used by other people. So I'm going to merge this one with master. To do that, I need to check out into the main branch. So this is done. So before merging, also verify that there are untracked files or not. There are no untracked files. Work tree is clean. It means that I can merge. You can check out the master. Now check the code. Wait, it is having the bug, but I fixed the bug in another timeline, right? Another universe I fixed the bug. Now I'm going to bring back changes to here, right? What I can do, I can enter git merge and the branch name. You can always enter bug or some kind of thing and press tab, right? Auto completion is there in this git bash. So I can enter like that. So something happened. Fast forward, it means that adding commits, like it is adding changes on top of the master's changes. So if I enter git log, so here's the change. My app is created. Those things are created. So fix the bug. I fix the bug, adding some stuff. So now you got the point. Now there is one branch, one thing, right? You can see this change. So in the master, I added bug fix commits, right? Bug fix changes. I think the changes I bring back here. Now you got the point. I think we covered branching and merging. Likewise, try to create branches, try to get things into here, but there is something called merge conflicts. Conflict means assume that you are working with two branches. It will happen some kind of in explain scenarios like this. I'm not going to demonstrate that, it will take time, so I will roughly explain. I will give a summary. So it means that you are working with bug fix. Master is there. If someone is modified, someone created another branch, maybe bug fix 2, then he's going to apply the code into master, merging to master. Then you are also going to update the same point. Maybe you change this hello into another name, but another developer also changed this hello into another name. So JIT cannot automatically detect such changes, right? The JIT has no like AI powered things to like detect such changes. So it will basically ask what change you need to apply, the another developer's change or your change. So that there is some kind of scenario. So maybe I think you can learn more about those things. Those are called merge conflicts. You can learn more about those things, because it will take time. It will take time if I demonstrate such thing. So now I'm going to explain about GitHub. Now you will know about what is JIT and how to use it, how to create repos. Now I'm going to show you what is GitHub. But I already told you. Now I'm going to show you practically what is GitHub and how you can share the code. So because this one is in your local computer, right? No one has there's a ways, there's several ways, right? You can let another developer to log in this one remotely using TeamViewer or something, then they can work on this one. But we are not going to do that. Developers usually work on their own computers, right? So I'm going to show you how you can share this code with other developers. So if you're working with project, so maybe a group project, you start in your own computer locally, then you are going to create remote repository, right, on GitHub. Then you are going to share the code, push the code, then another developer can get the code, they can update, they can implement things like that. So how you can do it? Just go to github.com. You will see something like this, but if you see this on first time, you will see something like this. So you need to first sign up, create account using your email, then you will see this kind of page. So how you are going to create repositories? So if you go to my profile, there are several repositories, right? There are several repositories. So those are remote repositories. This is local repository. So how you can create remote repository from this one? So what we are going to do is, there's a thing called create new repository. So if you go here, create new repository. So it will ask several things, but those are not needed. They are not creating this one from template. We are going to create from this one from scratch, right? So you're going to name it. Usually we name as like folder name, but it is not required. So I'm going to name, maybe it is not required. Maybe I can name another GitHub demo app, GitHub demo app. JS or something. So there are several things you cannot use. I think special characters. There are several things. It is better to use dash to separate the spaces. So you can enter description, something like that. But it is optional. So so you can say whether this is private or public. So public means everyone on the internet can see that, can browse your repository and can get the code, but they cannot submit the changes, right? It is public. So public means everybody can see but cannot update. You choose who can commit, right? You can give some privilege to special people, but everybody cannot commit, but they can see your content. So if you make it private, you can choose who can see, who can commit as well, but I am creating now public. Usually for open source project, we usually create public because everybody's contribution is needed, right? So these things are not needed. If you can add not needed means if you are creating a website, if you're creating a software, this is mandatory. You need to choose a license. But in right now, I am going to create example, right? So this is not needed. Readme is not needed. I will add it later. GIT no. So I will maybe explain after creating this one. So this is maybe previous things. Huh? So I will explain about this one. This is very simple thing. Maybe I can say it now. So maybe I can quickly say it now. So GITIGNO means, so if you are creating a website, so the application, this not website, if you are creating a project, so there can be some kind of things that you don't need to include into your repository, right? For an example, there can be log files. So if you have this kind of thing, so this is log files means it is created automatically for your computer, right? So these kind of things, you don't need to include these kind of things with your source code, because if there is some special, you mean security related things, everybody can see these things, right? So for these things, you can create a file called .gitigno. So if you create a file called .gitigno here, then if you add the file this .log here, I can show example. GITIGNO. Maybe I can show you some example in my one of my repositories. So there's a repository called this one. So I created the GITIGNO. It means, so I added, I think, log. So if I add this one, so when I enter GIT status, GIT add or something like that, those things won't be shown. Those things won't be included, right? So GITIGNO is a kind of way to ignore files. So I am not going to include such files, these files and these files, right? There. So if you are having some compiled binaries inside this one, not .exe or like that, so you are not going to include those things. So you can enter like such kind of things in this GITIGNO file. So those things won't be included there. So if you, when you are submitting code, so you cannot see log files or anything like that. But in your local, not repository, local folder, you can see those files, but those things are not present either in this local repository or the remote repository. So this is, but it is present actually in your computer, right? So it is a way to kind of ignore files. So you can check, I think, several examples like that to understand that further, because it is for special cases. So I will delete this one. So what I was doing, I was creating a repository. So I am going to now create the repository. It is public one. You also can try. Now it is created. Now GitHub is giving us a link. So we can use this link to submit code changes into this remote repository. So what I can do, so I can say it is status, no changes, right? So I am going to enter this command. I need to reference this remote repository from local repository. So git remote add. So I can name it. Usually we name as origin. Origin means this is the main kind of remote repository. For that I'm going to enter origin. So you can enter any name, but I usually enter origin, and we usually use that, right? But before that, if you enter git remote v, there's nothing, right? No remote references. It shows remote references. So no remote repository is linked. So I'm going to enter git remote add origin. I'm going to paste this one, enter. So now if I enter this one, I can show there are remote references. So there are remote references. So fetch means I can take the code from there. Push means I can push the code into there. So what I can do now, I can enter git push. The origin means this name, origin, and the branch name. Branch is master. So you can use new name main as well. Master is not, I think, used by any people. I mean, not any people. Some people use main and some people use master. So I am going to use master. So I will push this one. But before pushing, if you are pushing this one first time, with the new GitHub account, it will ask a password, right? It will ask password because I mentioned that everybody cannot push. You are the preferred people is going to push the code. So for that, you need to go there, go to settings, go to developer settings. And there's a personal access tokens, right? I created this one for this computer, but likewise you can create new token and it will provide a token, some kind of key. Then you can copy that one. Then when you enter git push origin master, it will ask a password. So instead of your password, don't enter your password or your GitHub password. You can enter this password, this copied token as the password. So I already entered, so it will not ask. So I can push. Now Git is going to automatically submit this repository changes into this one. So what is that? This one. So if I reload this one, I can see app.js is there. So if I browse the history means commits, I can see all the changes, right? My first app is created. I can see those versions as well. Using GitHub, it is easy to navigate, right? We have a GUI. If you click on here, you can see what is the commit. You can see browse priors as well. So this is my first version. So this is the first step. So later I change into this one. I think you can browse history like that. You can go to next version like that. Changes, all the things can be browsed, right? So that is about pushing. I think I mentioned about push. Pull means assume that another developer, you are going to share this one with another developer, right? Maybe you can ask another developer to please add the readme or something like that. About GUI. GUI means you mean this GUI. You mean this GUI means these things. So these things I will give introduction. So right now I am these things. Yeah, I will explain these things, but right now I need to cover these things. I think in this section I will remember to explain about actions. Actions, GIT-ignore, I already explained. GIT-ignore, I will explain about actions. Maybe I can add a note, action GUI. So right now I will cover this one and explain, right, these things. So push, pull I need to cover. Pull means assume that you are going to say, you are going to share this link to another person. You are going to ask, please add the readme. Read means some kind of documentation about this one. So right now you can share this link, right? This link to another person. So what they can do, they can follow the same thing. They can follow the same thing. They can copy this one. They can create a repository and add like that also, add like this also. But there's a quicker way. But they can do. Assume that this is another person's computer right now. Now I am going to create. Assume that this is another person. Another person's computer, right? I am in another person's computer. So what he's going to do, he's going to open the not this one. I'm going to open this one. Not I am. He's going to open this one. He's going to enter git clone and this one. What it does is it will fetch the latest code. So I am having local repository. Not I am. He's having local repository and the changes I did. So what he can do, he can modify this one. He can add a new feature. Maybe Vic is going to add the change. New feature. Now what he can do? This is another person's computer, no? Another person's computer. another person's computer as another person. I'm going to add this on. Add the feature. I'm going to push, but right now, no. Notice that the my signature is added. No, if you check the GitHub, this is not. This is also me, right? This is not the other person. Assume that this is from another person. This is from another person's computer. So if I check the code, so this is the new feature. Maybe this is from another person. So how now? Where's my computer? This is another person's computer. My computer. This is my computer. No? It's still another person's computer. I need to go to there. Another person's computer is there. This is my computer. So what I can do is still I am not having that change, right? Locally. On GitHub, I can browse the because it is centralized, no? I can see, but in here, since Git is decentralized, I am not having the change. So how can I can get it? What I can do is I can pull Git pull origin master. I am going to ask from Git, hey Git, please check the repo, check the remote repo, and get the content, get the latest changes to my master, my branch from master branch. So it is now updated, right? So if I can check this one, so it is updated, maybe by another person. Likewise, before working with, I think before adding changes, we usually enter git pull. Git pull. You can enter this command. I think you can enter this command, and you can enter git pull. But right now I entered just git pull origin master, right? Before we are submitting any change, we usually do this one because there can be changes by another person, right? If owner changes something, it will be also update our code. No, I mentioned that Git is decentralized, no? So let's assume that owner is going to add the readme. So this is demo. So this commit is done into remote repository, right? So assume that owner changed something. So it is there, but it is not automatically updating this one because it is decentralized, no? Not centralized part is only GitHub. Git is not centralized, so it don't update this one automatically. So to update this one, likewise, I think I already opened that one. No? There are a lot of things. I am going to close those things. To update this one, so if you see this one, if you see this directory, the readme is not there. No? To fetch that one, you need to make sure two things. So you need to make sure you are on the same branch. So there can be another branch. So I can create another branch as well. So if I enter test, create test branch there. Likewise, the remote repository also we can create branches. Likewise, I created earlier using git checkout, no? But here I can click and create. So if in test branch I did something, and if you are on master branch, and if you are just pulling that one, you won't see the changes, right? To see that, you need to make sure two things. First, you need to make sure that you are on the same branch, master. Then you need to make sure that you enter git pull in master, right? It is not there. See what happens. Now the readme is there. You need to make sure two things. Make sure that you are on the same branch. Then you make sure to enter git pull origin, the branch name. So likewise, I think you can shorten this one by entering that command as well. Maybe I can show you. We usually enter git pull. You can enter this one. Branch means master, right? It says that always I need to consider fetching things when I enter git pull. I need to take things from master to master. So now if I enter git pull, I can get the page just directly. No need to enter those such things, right? Git fetch origin master. So git pull is enough. So now I covered, I think, now I think I answered this thing also. It won't update if I change something from remote, it won't update the local report directly because it is decentralized. So you need to enter, make sure that first you are on the same branch, then you need to enter git pull or git pull origin master or the branch name. So that's how it works. You need to manually fetch the changes. Otherwise, the developer's in trouble. You know, if someone changes that one, someone breaks something in there, then your code is also broken. So Git is and GitHub is not going to do that, right? And there's a kind of flow. You need to enter git pull to get the changes. So I can continue into next section now. So this is the thing, I think, most awaited things by the persons who asked the questions, I think. So I am going to show you some features in GitHub. So usually we work with open source projects, no? The open source means some repositories, right? So we also discussed some kind of things like pushing and pulling. So those are the not only features on GitHub, there are a lot of things, right? I will give kind of quick overview about this GUI and also some features, right? So first, the code means your code. You can create branches, see branches, and do whatever you need. You can edit files as well from here. You can edit, right? But you cannot test, right? Because you need to download pull the code in to test in order to test, right? You can if it is markdown, you can preview the changes. Markdown means some kind of documentation related things. There is a special command, right? So if you need to add the list, you can add dash like that. Then you can see the changes, right? And you can commit, right? There are some file editing features like that in code. Also you can browse among the commits. I think this is another person because I think I committed from another email, right? Email is kind of unique key to identify users. So you can browse the code, you can do stuff like that in here. You can add new files, create new file, I can create new files, and you can search for files like that. You can basically browse the code from this one. You can have some kind of things in here as well. Issue means some kind of way to track the progress or track issues, bugs, something like that. So if you need to track, like if you need to mention that you assume that there's a bug in code, so you can create a new issue. Please fix the bug and bug description, something like that. In here you can explain whatever, like that. You can use markdown as well, like I mentioned. So you can create this one. You can assign persons, so you can do things like that. It is like project management here. Then when you are committing, you can mention that when you're committing, just to add files, then you can mention that issue as well, like that. #1 means this first issue, #1. You can then the commit will appear here. Likewise, there are things, right? And maybe I can show example. First, I'm going to pull the code. Test will come, no? It is not updated here. So I'm going to maybe create a file, new file, bug fix. So I'm going to fix that issue. So I'm going to push it. So now it is pushed. So what will happen? If I go there, I can see. So I fixed it. How I fix it? Like by adding a file, right? So likewise, now we can close this one. Oh, it is fixed. You can commit. Likewise, it is about issues. Pull request means, so you can someone can fork this one. Fork means someone can make a copy of this one. So usually people don't submit. I mean, if this is maybe I can show another example. So this is my one of project. So usually people will submit changes to this one. So if I check commit history, I am not the one working on this project. So people will submit. This is not the great example. I think there are some commits from other people. Maybe this one. like if there are people committing, right? So these to submit these things, people directly don't push this one because they don't have access. They don't push directly into this one, this repository. So what they are going to do is they are going to fork this one. Fork means they are going to make a copy of this one. So if I make a copy of this one, I think I already created, so this is my copy. So I am going to implement changes here. Then I am going to make a pull request. So pull request means, I can show one example by another person. So this person did the fix, right? So he submitted the pull request. So he's saying that, hey, I fixed this one. So these are the things, these are the modifications. So I would like to submit the change into the main code, right? Main code. So what I did was I said thanks. Then I clicked, there was a button, merge. Merge means basically merging his code into his submitted code into this branch, this main branch. So now his change is in my code, right? My means the main code. Likewise, so pull request is a way to submit code by copying the repository and implement something, then submit things into this main repository. So they are not going to directly push code because they don't have permissions, right? So I am the one having some kind of permission to write this one. So what they can do, they can submit pull request. So I can check, I can approve and merge, right? So their changes and their commits are added now because they submitted their things. I merged, right? So I think I need to say about actions and GUI. Let's cover the GUI part. So we checked about pull requests. It is a basically way to submit changes, right? So if you are working with, I think maybe a group project, you can directly push the code into repository, because you can enable permissions. I think if you go to settings, manage access, and now I need to enter the password. But if you go there to manage access, you can add people who is going to push, who can push into the code into this repository, right? So they can directly push. But when there are a lot of people, it is hard to add permissions, no, for each one. Then they can submit pull request. They can fork it. Then they can they implement things in their own repository. They are like copy of their repository, copy of this one. Then they can make pull request. So the owner can check and merge, right? So that's how the basically open source software development works. I can show in maybe next this section. So in the GUI actions, I will tell, I think a bit later after checking the GUI. It is part of GUI, but I will tell it later, right? In this section maybe. Actions is going to be added into this section because it is kind of optional for the things, right? So projects mean some kind of, you work with Trello or something like that, no? It is like Trello. Some you can add issues into several list, to-do list, finish list, something like that. Then you can manage the work. You can assign things like that. In the wiki, you can create documentation. You can create documentation like that. You can write this stuff like, hey, how this works. Likewise, you can write documentation. You can write documentation from here as well, but it is a single kind of stuff, no, single location. But if there are a lot of things, you can add here by creating a lot of pages, something like that. Security means if GitHub detects some kind of security issues in your code, it will show here. So I am getting some issues like that. Code scanning alert. So for the code scanning, I am not having any kind of setup. So I can set up some kind of code scanning things, something like that. The security related things are coming from GitHub. GitHub says what are the security vulnerabilities in your code. So it is going to submit something like that, submit some issues. So these issues, they are something like that. I mean, some security related issues, right? Security. So insights means some kind of statistics about your project. So who are the contributors? Right now only me, but I think if you check here, there are a lot of contributors. I think there are contributors. So how they are working, then how about the community? Community means is there kind of license there, such stuff, right? Traffic, how many people visiting this website, some stuff. So what are the traffic sources, something like that. In the settings section, maybe this settings section, you can rename the repository. You can, I think, do a lot of things. You can enable things. Basically, these are like just configurations. I think you can go there and try to do stuff, right? It is. I think there are a lot of things to explain. I think you can just go to settings and try browsing each thing. Some of things will ask for password. Just enter and continue. So now I covered GUI. I think then I will show you actions and also how the open source project developers are going to work. So for an example, I am currently working on a project called this neutral Node.js. So it is basically kind of software development framework, desktop application development framework, right? So I will explain how we are working, how we are developing things, right? So what we usually do is we usually have a main branch called main master, not master branch, so kind of base branch called main. So this is the main branch, so it is updated and people can clone and fix bugs, fix things, and submit a pull request like us. So if you go to pull request, there are a lot of pull requests. People will submit things, no, they will fix stuff and they will submit. So I usually merge those things. So that's how it works. So we can commit and communicate like that. So after that, we use issues. So each these things are created by another person. So for an example, then another person added a feature request. So he mentioned that they need this feature. They need the feature to get a download directory or something like that, some project related feature. So I can add this label. So why label? Why I added label? Label means if I go to the here, go to labels, so I can browse easily, right? If I need to see all Linux related features, Linux related things, I can click and see, right? So this is about labels. So you can label issues. So pull requests are there. Discussions means some kind of chats, some kind of things. If one developer has some issues, they can start a discussion. Then I think someone can answer. Maybe answer done. Can check for example this one. So we can answer like that. Discussions, and then it comes to actions. Actions means some code, some project development work has some unit test. No, unit test means if one developer, I mean, let's say another developer edit this file, maybe he did a mistake in there, maybe kind of adding some kind of a variable that doesn't exist, right? So there's some kind of compilation issue, right? So assume that he mistakenly submitted that one and created a pull request. So if I directly go ahead and without checking anything, if I merge it, what will happen? The entire main means main project, the main branch will break. No, it will, if someone cloned it, their code also broken. So there's a risk in there. So the risk is there because if someone submit code that is broken, so we need to have some kind of way to check this on whether a specific change is working or not, whether it is having some issues. So what we can do is we can create a GitHub action. Action means then if someone is going to add the change, we can run some kind of test cases or run some kind of action, and we can verify whether everything is working fine. So what I did was I created this one. Inside the GitHub, I created the workflow. So Git actions has workflows. I created this workflow. In there, I am saying that this will run on push. If someone push the code, if someone make a pull request or in a schedule, I can run it manually or evening or morning likewise. So if such event happens, this thing will happen. This project will be built on Linux. So it will be built on Ubuntu platform. It will run this command and it will finally build the project. So if it will run this build Linux, right? It will try to automatically build this one on GitHub servers. So build, so it will GitHub will automatically execute this one. This is basically compiling the source code, right? So if there's any issue, any compilation issue, I can see that. So if this commit, so if this commit has some issues, if I click on this one, these are the actions. These are the actions according with that specific workflow. So if I click on this one, this is one flow action. This is one action. It is for building this particular thing, this particular source code on Linux, right? It will try to clone the repository on a GitHub server, right? These things will happen on a GitHub server when someone changes their code. So it is first going to check out it. Check out means clone it. Then it is going to build it. So if there is any failure, there is no failure. It is compiled successfully. No, if it is not compiled, I can show you one example. It will add this sign. I think this sign. Then I can see, hey, this is broken now. Linux, on Linux, it is not building. I can see why. So GitHub action is a way to kind of make sure your code is working fine or not by building your project on a GitHub server. So these things are happening inside GitHub servers, right? So I can see, hey, this is some kind of issue. There's some kind of issue. So I can go ahead and fix that, right? So on pull request also, if someone submit maybe this one as example, he submitted this one, another person submitted this one, but some checks are failed. You know, I can see. Then I can mention the developer, hey, please check. There's an issue. So likewise, I can mention. Then he can fix, and again he can submit changes. Then these things will be executed again, right? Then I can merge when these things are passing. These checks are passing. I think you got the point. The actions are basically a way to check whether your project is working fine. These are like jobs, workflows. So when it can execute, those actions can be executed when there's a change, there's a push, there's a kind of a code change appearing in here, or when there's a kind of a pull request. So we can verify whether everything is working right. So otherwise we will merge things that are not working right. Then all the people are in trouble because there's not working stuff inside the main repository, main branch. Now I think I covered things. Time is also closing to the end. I think I think go to the conclusion. So I explained about GY, that is fine. Actions also, I guess the person who asked could answer. So if there's more questions, you can, I think, ask from the Q&A session. Probably I think there will be Q&A session. So I think those questions are over. So I covered this thing. I will quickly mention what I covered. So we learned about GIT and GitHub, the theoretical things, why we are having a need to use GIT and GitHub, right? So after that, we learned about some kind of practical ways to use GIT and GitHub, how you can use GIT and GitHub on your projects, on your group projects. I think now you can use GIT and GitHub with your project, right? When you are working with the University project, you can easily use, right? To save the time, because you don't need any kind of Google Drive or something like that to share the code. You can create a repository, you can push the code, that's it, right? Then another developer can pull the code and work. Then they can also submit the changes, right? That is very easy workflow. But make sure this flow, this is very important. Everything in JIT is like kind of a tree or graph, right? There are nodes, there are connections. So they are working on different flows, they are merging. Some flows never merging to the master. So like that, some changes will be merging to master like this one. So the flow is very important. So as the next steps, I will maybe suggest these things. First, you can learn more about open source development. So in 99x also there is organization. So in the organization, we are working with several projects, right? Apart from our main work with the customers, we work with open source projects. So you can browse this one. So for an example, we work with this one recently. This is a kind of software tool, software mobile application to for competition, for running working competition. So you can browse and read documentation. So if there is any mistake or something like that, you can submit a pull request, right? Then now I can show you how I can merge. So there's a pull request. This is automatically added, right? To update the package. You know about package, those are dependencies, right? Then I can check the changes. Maybe it is just a package update. I can assume that those things are okay. I can check checks. Build also successful. Actions also fine. Then I can merge this one, right? How I can merge this one? I can maybe add a commit. This is about no. I am not going to add the commit because it is not going to read this one. So I am going to merge. Now this change is applied. This is how we work. We usually work with pull requests. Now, if I merge this one, the actions will automatically run, no? Because there's a change in repository. We need to make sure everything is right. Then it is executing these things. Now we can see actions are running, right? Likewise, now it is installing dependencies, right? Everything is going to work. If everything is successful, we can see this green tick. Now we are in a safe state, right? Nothing is broken, everything is good. Likewise, I mentioned about what you need to do. So next, you can check our maybe open source repositories. In here, also we develop open source software. Then you can learn how we develop. And there's a website called this one. So there also we create open source projects. So I showed you about this project. There are the projects as well. So you can see those projects. Then you can also see the source code behind those projects. You can basically browse GitHub repositories, right? Then you can learn about the practices we follow, how we develop things, how we make repositories, and how we create branches, right? For each version, we usually create a branch. Likewise, you can learn more about those things, right? And as a next step, as I mentioned, I will suggest you to go to GitHub repositories and find interesting stuff. So if something is interesting, you can contribute, you can add the issue there, you can make a pull request, then you can get started with open source software development, right? I think this concludes the presentation and the tutorial. So I will wish you happy coding with GitHub. So if you want to contribute, you can check our company repositories, and also you can use you can see this website as a project. So thank you very much for inviting me, and have a great day.
So now, if anyone has any question or doubt you have regarding today's session to be cleared out by the speaker, you all can use the chat box, or else you all can unmute your mic now and speak out your question.
Welcome, thank you very much. As a next step, as a next step, I mean, you can check GitHub repositories likewise. So that's it.
So now our program has come to an end. And on behalf of the Department of Information and Communication Technology of the Faculty of Humanities and Social Sciences of the University of Sri Jayewardenepura, I would like to thank Mr. Shalita Suranga for stimulating and insightful lecture. I think we all were able to extract the key essence of your valuable lecture and gain a good understanding about Git and GitHub. Thank you again, sir, for taking time from your busy schedule to enlighten us today. And also, I would like to thank all of today's participants for your active participation. And see you all again in another valuable guest lecture.